All right, so prior to this, we could find a z-score and a probability given an x value. Now we're going to start to learn how to go backwards. Okay, so what we're going to do is we're going to look up the probability, find the z-score that corresponds to this number, 3632. All right? Now, I'm not going to do all these this way, but just to remind you. So we're going to look at our chart for 3632. All right? So it's just kind of a, where's Waldo? So you're looking for 3632, and boom, there it is. All right? So that's going to be negative 0.3, 0, 1, 2, 3, 4, 5. So negative 0.35. All right? Find the z-score that has 10.7.5 to its right. Well, first off, to the right, that's one of our 1 minus problems. And then 10.75 is 0.1075. So that is 0.8925. And if you go to your chart, obviously to the right of that number, 0.8925, we're going to be on the other chart. You're going to look for 0.8925 on that chart. And that is going to give you a z-score of 1.24. All right, 80th percentile. So that means 0.8000. All right, so you're going to look at the chart. Obviously, it's going to be on the positive side. 80th percentile is above 50th percentile. So it's going to be on the right side. And you're just looking for 0.8. The closest thing is 0.8000. You're not going to find it exactly. So if you look at 0.85 is 0.8023. And 0.84 is 0.7995. Now we talked about this in class. So it's between 0.7995 and 0.8023. Now, what does this correspond to? Well, 0.7995 is 0.84, and this is 0.85. I would accept either one of those answers, but if you really want to be the most accurate, you would use a z-score of 0.845, which is halfway in between those two. I would accept any one of those three answers, all right? You can go a little bit above, a little bit below, or kind of split the difference and just tack on a 5 to the end of the smaller one. You choose. I'm open to that. Okay, 50th percentile, that's 0.5000. Let's make that look like a 5. All right? Now, when you do that, there's not really much to think about here. That's half of it. So that is exactly the z-score of 0. It's on the upper left-hand corner, 0.00. So that's it. Okay, first quartile. If you think about quartiles, we talked about this with Boston-Wisher plots. That's 25%. So we're looking for 0.2500. Now when you do that, of course, that's going to be on the left side, the negative side of the z-chart. I will accept negative 0.67. I would accept negative 0.68, and the most accurate would be negative 0.675. Again, any one of those three is acceptable. Now the second quartile would be 25 and 25, so 50%, which we've already answered up here. That's 0.5000. Again, that did not want to be a 5. And that's going to be a z-score of 0. That's the middle. All right, now, you saw in the Tall Persons Club how we took and found the x value from the z-score, and we did this. Z equals the actual minus the mean divided by the standard deviation. Well, this is the same formula, just restructured, because think about it. Didn't we multiply times the standard deviation, and then we moved this over by adding the mean? That's all we're doing here. So the actual score is the mean plus the z-score times the standard deviation. It's just a quicker way of doing the math. So, if we have a mean of 67, and we have a standard deviation of 4, and we have these three scores, we're just going to do the formula. X equals the mean plus the z-score times standard deviation. Remember to do this in your calculator first, hit enter, and then add 67. So that's 74.84. For this one, x is going to be equal to 67 again, plus negative 2.33 times the standard deviation of 4, and that's 57.68. And this one, technically you should already hopefully know that, but see why it works out. 67 plus z-score times the standard deviation, which is just 67. So a 0 z-score is the mean. Now, let's real quickly look at this. I want you to sketch this real quick. Won't take very long. Here's our mean at 67. And then we have our three numbers this way, three numbers this way. And we're going to have 71, 75, 79. And 63, and 59, and 54. Sorry, 55. Okay? Adding 4 and subtracting 4 each time. All right, real quickly. This is plus 1, plus 2, plus 3. Minus 1, minus 2, minus 3. And let's look where these numbers are. 74.84. That's really close to 75, which is 2 standard deviations away. Isn't 1.96 really close to a z-score of 2? It is. Hope you're starting to see the relationship of these. 57.68. Well, that's going to be between 55 and 59. Well, doesn't that make sense? That that's going to be between negative 2 and negative 3? And there's my z-score between negative 2 and negative 3. Hopefully it's starting to make a little bit more sense to you. Okay. We have a mean of 75. Standard deviation of 6.5. Top 5%. That means we're going to use 0.95 and go from there. Okay? So we look up 9,500. That's going to be a z-score between 1.64 and 1.65. I'm going to use the most exact one for this. And then we're just going to use our formula we just learned. X is going to be equal to the mean plus the standard deviation z-score times the standard deviation. And that gives us a score of 85.7. Well, again, let's just draw a real quick sketch. All right? I'm just going to do the right side. So I have 75 right here. Then I'm going to have 81.5. And then I'm going to have 88. And then I'm going to have 94.5. Well, where would 85.7 be? Right about there. Okay? Well, let's think about it. This is 50% right here. Plus 34. So that's 84%. If that whole area is 13.5%, then that makes sense, and that's about 95% right there. All right. Next example. We have scores, okay? Mean is 6.84, we can see that right here. and a standard deviation of 1.55. All the numbers have already been done for us. So we're looking for a score less than 4. Well, where would that be? Well, that would be between -1 and -2. So when we get our answer, we should be somewhere between -1 and -2. It's good to kind of put that in our head so that when we get to our answer, if we get something that doesn't fit in there, we did something wrong. So we take our score of 4 minus our mean and divide by our standard deviation. And what do we get? We get a z-score of -1.83. Does that fall within here? It does. Now we look that up on our chart, and we get 0.0336, or we can write it as 3.36%. Either one, that's our probability of scoring below less than a 4. Now, it said what test score would place him at the 90th percentile. Okay, so that's 0.9000. So again, we're going to look for approximately 0.9000. And that's going to be between a z-score of 1.28 and 1.29. Okay? So I'm going to use 1.285 to be the most accurate. So I'm going to take 6.84 plus 1.285 times 1.55. And that's going to give me a score of 8.83. Now, where's 8.83? Right about there. Between 1 and 2. And isn't that what we said we expected, between 1 and 2? It's obviously going to be closer to 8.3 than 9.9, so that's why it's a little bit on the low side. All right, last examples. We have our information here. Mean of 170, standard deviation of 30. Real quickly, just going to sketch this out. 170. That's going to be 200, 230, and 260. And then on this side, it's going to be 140, 110, and 80. Just so we have something to refer to. That's a skewed. It doesn't look very normal. It's skewed right, but you know what I'm going for. So, 240. We're looking for greater than 240. As soon as I see greater than, above 240, I got to have my 1 minus in here. So, 240 minus 170 divided by 30. And that gives me a score of 2.33. That's my z-score. So when I look that up, and we already have used that number a few times in our worksheet previously, 2.33 gives me a score of 0.9901. And when I subtract that, I get 0.0099, or 0.99%. That's the odds of being above that number. All right. So, people with cholesterol levels between 200 and 240. Well, we've already done 240. We just need to do 200. So 200 minus 170 divided by 30. And that gives me a score of, well, exactly 1.0. Okay? And that makes sense because where's 200? Right there. At exactly 1. 240 is a little bit above right there. A little bit above 2. So, this gives me a number of 0.8413. So if I do 0.9901 minus 0.8413, I get 0.1488, or 14.88%. So almost 15% will be between those two numbers. And last but not least, what cholesterol level would place a 14-year-old boy at the 10th percentile? Okay, so that's 0.1000. So we're going to say x is equal to negative 2.33 times 30, sorry, I did this backwards, plus 170. And that is 100.1. Which, if you think about it, that makes sense. That would be right about there. Between -2 and -3. That's it.